Well, as is often the case, I need to kind of go back and revisit something to kind of clear something up a little bit. With all of these compounds, if I were to kind of put a little star next to the middle atom, you would in each case tell me that there are four things, sigma bonds, lone pair electrons, extending from that atom. So 4 actually then, remember we said, is associated with sp3 hybridization, and it's tetrahedral in shape. That would be fine, and we said that that bond angle then is what? The bond angle is 109.5 degrees. Okay, and I'm here to tell you that if you get these on the test, that's what you're going to tell me. But I actually want to revisit these as kind of collectively and show you how the bond angle actually is a little bit different for these guys. It's not exactly 109.5, and I'll tell you right off the bat, the reason it's not exactly 109.5 is because it doesn't have equal kind of situation with regard to the types of activities those hybridized orbitals are participating in. Okay, and let me show you what this looks like. So these are structures of, this one would be exactly 109.5, these bond angles, and I'm going to kind of show you, well, I'll just tell you right now, this bond angle is a little less than 109.5. And I like to tell students, I kind of think of this region of space, this repulsion that this lone pair electron is doing, actually is a little bit, I'm kind of draw it fat. It kind of makes these things kind of squeeze down a little bit more, so that we're going to see that this is less than 109.5. Okay, and so guess what? When we get to the water molecule, where actually you have two fat things up there squeezing even more, this actually is even less than 109, less than 109.5. So actually that bond angle is the least here, and then followed by this one, and this one is exactly 109.5 degrees. Okay, so that's kind of in a nutshell what we have going on. So this is kind of showing you that, yeah, with methane we're at the, we're looking at we're looking at sp3 orbital hybridization. It's the classic. And honestly, if you kind of continue in chemistry, how do I say this? The fact that there are four equal things, specifically equal to the point of not just that they're sigma bonds, but that they're connected to the same thing, actually is significant in getting the specific geometry. But it'll be tetrahedral. They're all tetrahedral, just their bond angle is a little different. Okay, here we said, I told you how kind of think of this lone pair electrons up here as kind of being kind of fatter than a sigma bond, and so these things are kind of squished down, less than 109.5. And here we have, they're all three tetrahedral, but your lone pair electrons kind of squish those hydrogens down even further. Okay, so here we have some numbers to go along with what I was just telling you. That again, the methane, since it's connected sigma bonds to actually four equal atoms, it's 109.5, ammonia a little less, 107, and water a little less than that, 105 degrees. But put another way, if you put 109.5 degrees, that's what I'm looking for these guys. Okay? Yes. Let me know if you have any questions.